I think the 30 seconds has passed, so I'll kickstart it and the rest of the team will join us. Hi everyone. My name is Godfrey Kutumela, and I'm part of the Cross Lake core team that is contributing to this project. I've been part of it for the past more than 2 years. And in this work stream, really we'll be focusing on just quickly giving a high-level highlight of all the activities that we had, this PI, starting with the objectives we set and making sure that everyone else can see and have a full visibility of what we do. And in this work stream, I've got core team members that contribute to this, Victor, Amy, as well as Tom Daly and Louis, and other supporting team members that we have here that are part of the work stream. So just to kickstart it, I would like to introduce for those that are new to Mojaloop, just a little quick overview about what the workstream does and why we do it and how we do it. So essentially, we are a dedicated workstream that is looking at improving the trust of the Mojaloop platform. And we're doing that, to make sure that we are in line with the level 1 principles around data privacy and also protections against the trust and the integrity of the system, so that when we push for more and more adoptions, we will know that our system is robust and is able to withstand, any of the cybersecurity and internal threats. And how we deliver that is really through mainly, working with the functionality team to bake into security into the core architecture of the platform. And also we have a number of, initiatives that we start as part of the work stream to make sure that we add more and more non-functionality elements of it. And obviously we take a risk-centric model since this is about security. And we also look at the standards and the controls that are well known. So we don't try to invent anything new, and we just look at all the best practice that we need to have as part of our software development project here. The milestones here speaks for themselves, just in a nutshell, where we started in PI 8 and where we are in the current phase. Zooming more into the current PI that we just came from, I just summarize this because of time so that you can have a full visibility on the objectives we set for ourselves and as well as the key topics, around each and every of those objectives. So we've divided this work into separate epics, which some are long-lived. They can go multiple PIs, and some can actually start and end depending with the scope of that work. This actually helps us to be able to bring in different teams at different times to come and contribute to specific areas. And in this session, we'll not dive deep into all of them, but we'll just actually pick a few of those. The first one around K8 security, as well as identity and access management, data protection, and DevSecOps. So we'll actually have the team here that I have, Amy and Victor, will actually drill into those 5 ones. And the other ones, we've got all the information available on GitHub. And that's the link that we use for our GitHub bot. So should anybody at any point wants to get a little bit more beyond what we're going to present today, you are welcome to reach out to me directly. So in terms of the objectives are well set per epic. And also, part of that is really to identify the addressable scope that we can actually cover within the PI. And then the subsequent slides will actually cover all that. Starting with what we do around the DevSecOps, this is really the core of our software factory. And here, the bigger task has been done from the inception of the project when we set up all the different processes around our code promotions and code releases. So what actually we do from PI to PI here is really to maintain that, from a support perspective to ensure that, all the checks and balances around our software patches and our updates are running. So for that, we've got a couple of tools that we've put in place, like the depender bots for, all the security alerts. And we continuously check all the alerts that comes through and look at where we need to address them. And we have license scans running. We've got NPM that is actually doing that on specific repos. And also for improvements, we looked into how we can actually manage to automate the releases and also overall improvements of our CI/CD workflow. So those are in a nutshell what actually we did in the session. And over and above that, we actually also had a look at how we're actually managing the repos today. So there was a very good exercise that covers across multiple teams, wherein we looked at the best practice recommendation from GitHub themselves, and we used that to actually formulate our own strategy on keeping a single instance of the Mojaloop organization and doing all the actually recommended maintenance and routine work that we need to do from time to time. So that is in a nutshell what we've covered in this space. In addition to that, I've mentioned that we from time to time baseline the tools we have against some of the good tools. And we're still happy with MPM audit from a license perspective. So what we have actually just done here is from the last scans that we did, we gave a map of all the licenses that we use today, from an open source library perspective. And this actually attests to what Mila has indicated around trying to stay as much as possible from restrictive licenses to try and make ourselves as much more attractive to people to come adopt us. So as you can see, all the libraries that reflect here on the top end is mainly, MIT, BSD, and ISC, and Apache as well. And all these are permissible licenses, and they're also incompatible with our organization-wide license classification of Mozilla 2.0. And anything else that we allow here, it has to be compatible either with Apache or Mozilla 2.0. Otherwise, we will flag it and make sure that we can actually deal with it as an exception. But as a matter of rule, this is really how our license landscape today looks. Going to the the new epic that we just started in this PI around K8 security. We actually looked at this very deeply before, but much of the work around this have been done as part of the hub implementation by the implementers. But we were moving the boundaries. So from time to time, we're looking at what are all those addressable areas, that we can actually bring in so that when somebody takes Mojaloop and adopt it, the default configuration can give them a very good start from a security perspective. So here we're looking at all the 4 C's of cloud native security from, cloud, container, as well as, all the aspect that goes with it. But for this PI, we just picked, a scope wherein we look at the cluster and the networking communication within the cluster. And what we looked at as part of our current kind of like generic deployment was everything else was open, which actually increases the attack surface. So if we have any port talking to any port on the ingress and egress, it can actually cause a problem, provided people adopt it and they don't actually do anything about it. So in this epics, we really wanted to address issues similar to this, and also to make sure that the greater the smaller the attack surface and the compartmentalization of the space within the container environment will actually help us to reduce the risk drastically. In terms of our approach here, we set up a mini loop deployment environment as a workbench that we will use just to showcase how best we can limit traffic from one port to another, one cluster to another. And we started well. We got the environment up and running and tested all the releases and installed all the DBs that we need. And the next phase in the next PI is really to start putting more policies. We've already adopted Calico as a mechanism for us to control networking solution within the container environment. And we're also investigating OPA Gatekeeper as a possible replacement for port securities, whose guarantees within the Kubernetes security architecture is not guaranteed at this point in time. So going forward, we look at what are other possible solutions that we can actually bring into the space. So this is actually ongoing, and the next PI will be able to demonstrate the policies that we have, and we'll be able to take this and migrate it into our lab environment, where we can actually show how it works, and also to test against some of the performance matrices that we have established to make sure that bringing in this it does not actually hamper on the current existing performance thresholds. And with that, I'll quickly hand over to Victor, who will cover the CI/CD process, the MPQS Lab, as well as the OS and DB hardening. Victor, over to you.
Yeah. Thank you, Godfrey, and hello, everyone. Thanks, Godfrey, for the CQS summary and a highlight of our key focus area. I am grateful for the opportunity to be here, as well as contribute to Mojaloop. So as Godfrey said, my name is Victor Akidiva, and I'm a security architect within Modusbox. And we are part of the team that has been contributing towards the Mojaloop development for a while now, with our specific focus being on security. So I'm sure most of us know that with over 3,950 confirmed breaches globally in 2020, security is getting center stage. And I want to focus just a few minutes to give a high-level overview of some of the key areas we've been focusing in code quality stream around code security. So our next slide, please. Godfrey, next slide. Yeah. So our efforts in this PI were focused around deployment of the MPQS Lab, looking at CI/CD security enhancements. This is in line with what Godfrey touched on earlier around the release, the repo management. And then finally, we did some benchmarking of some of the Mojaloop components within our lab environment using some of the best practice standards that we have identified, which we have analyzed and believe are most relevant towards payment systems. So from a CI/CD perspective, we all understand that there is need for safe and secure software, or our technology-driven livelihoods may be at risk. With the increasing security breaches, we need to make sure that we have visibility into what's happening within our release pipeline from the code inception up to the point when the code is deployed onto production. Overall, our security posture will enhance our credibility in the market. It will build trust with our customers. And with that in mind, we're going to look at some of the key areas we looked at within our CI/CD area where we can enhance. So our PI objective involved reviewing the security policies in use in our CI/CD pipeline within Circle CI. And here we were looking at the Anchor engine that scans our containers, as well as the NPM Node.js audit script that is also used, both of which are open source. The idea here was we wanted to ask ourselves a couple of questions around this. And this involved reviewing the pipeline, reviewing some of the YAML config files within each Mojaloop component to see what scan policies have been activated, looking at the end-to-end release process and having chats even with some of the development team members to understand the experience and process on a day-to-day basis, identify any gaps as guided by some best practice standards, and then report on any gaps and areas of improvement. Some key questions we asked ourselves were, A, do we have a documented CI/CD triage process, which includes escalation, remediation, and exception processes? Because we understand there might be need to exempt some areas and there might be need to engage with various stakeholders as part of the security remediation process. Are our dev and engineering and product teams aware of some of the security risks that may come about from their day-to-day tasks in contributing towards Mojaloop development? This is from an awareness perspective. What are some of the best practice standards that we could use to guide us going forward within our CI/CD process to avoid inventing the wheel, of course? Are we able to keep track of our licenses, our code libraries are used within Mojaloop repos, etc.? Godfrey has already touched on that, and we are really doing well on that area. How do we keep track of our CI/CD security maturity to ensure we have a constant improvement process to align with the changing in application and software environment as more and better tools keep coming about? So some of our key findings include that we still have Anchor CLI configured as part of the release process. However, there seems to be some issue with the running of the engine because I was not able to identify scans being picked from Anchor CLI. We are still reviewing this with the Mojaloop team to identify what could be the issue. We also identified that there is a process where NPM scanning can be bypassed by using the audit the JSON script that can be uploaded as part of the PR process. Again, this is being looked at with the team to try and resolve the issue. We also identified that there is a high-level remediation process in place for analyzing the output and resolving the issue that have been identified, but it's not documented with clear guidelines of how to escalate, who to escalate to, and how to handle probably code output that cannot be resolved. And then finally, we also identified that there is need for increased awareness within our development teams to be able to understand the risks that can come up within the process. So from a recommendation perspective, quickly, we need to document our security bug triage process. This is currently ongoing. We need to conduct awareness on a regular session for our dev team as well as the other teams that contribute to Mojaloop. We need to find a way to enforce breaking scans within the release process to prevent progression onto the next stage, especially with high risk vulnerabilities that may be identified. We also need to explore and document a Mojaloop-centric DevSecOps maturity model so that we can keep on self-evaluating and tracking our progress as we proceed over time. Now here we have a slide talking about some of the CI/CD pipeline tests. You can see here the central ledger was being tested, and from the vulnerability check, there was a failure. And the audit results.json file contains the findings which can be analyzed by the team members and reviewed for resolution. The audit JSON file can also be used as part of the process to skip the check based on need basis as seen fit by the development team. Next, please, Godfrey. Next highlight story was the MPQS Lab Setup, which was a mother story carrying a number of other stories within it. The objective here was to establish our own environment where we can test the best practice standards, test some of the security configurations, and implement the best practice standards that have already been documented earlier. So we took a bit of time getting the lab up and running. And once we got it installed and implemented with all Mojaloop services running, we started by doing the database benchmarking using the CIS benchmarks. We were also able to run the operating system benchmarking with CIS benchmark as well. And then we did container and package scans based on the Helm release that we had picked for the deployment. Now, this tied back to the initial story around CI/CD because we were able to correlate whether we are able to still find vulnerabilities within an implementation as opposed to how they should have been picked within the CI/CD process. Now, going forward, we are planning to do additional benchmarks around Kubernetes, the Kafka setup, the entire end-to-end communication and other components that are used at infrastructure level to make sure that we are able to document and test hardening configurations that can be taken up by deployment teams. Key recommendations here was we need to keep on using updated packages during the release process. We are going to document a security hardening guide for some of the Mojaloop applications and databases. This will be part of the overall documentation that we release. And then we have requested the Mojaloop team to consider upgrading to Ubuntu 18.04 and above because Ubuntu 16.04, which is currently used, is also is actually end of life from April 2021. This means that from a support perspective and from a compliance perspective, we need to consider moving to a higher version. And then we also noted the average CIS benchmark score was 33% for the Ubuntu 16.04, which was being used. So if we upgrade to the higher version and then harden the environments, we should see a higher score for the components. Finally, we noted that audit trains are not enabled at operating system and databases. And this is part of the reason why we have the lab setup, because in the next PI, we're going to explore enabling of these audit configurations. And then we can also see if we can set up some sample dashboards that security teams and monitoring teams can be able to track what is happening within the databases in the lab. This will involve also testing and deploying EFK to test SIEM capabilities within the MPQS lab. The next slide, I'm going to skip it because of time. It highlights some of the database recommendations that we had identified from the CIS benchmarking. They talk about enabling audit, disabling some of the sensitive settings that can allow, for example, uploading of files and executing them within the database. And these are more or less best practice standards that apply across all databases. And more information can be found if you check the GitHub storyline around DB benchmarking. With that, I'd like to hand over to Amy so that she can close off with the demo on crypto structure. Thank you.
Thank you, Victor.
Over to you, Amy.
Yes. Can you hear me, Godfrey?
Yeah, I can hear you. You can continue.
Okay, I'm just going to share my desk.
Share from your side.
Okay. Can you see my desk?
Yeah. Again, go ahead.
Okay, my name is Mpqs. I'm a solutions architect. So I am going to talk about the implementation that we've started doing in a development demo environment. And today we will be demonstrating the user registration using FIDO user authentication. Behind the registration, what we have is a FIDO server, a user database, an authenticator. In this case, we are using YubiKey. We've started building the CPM function, the CPM component in the Kubernetes environment with one function, which is a digital signature verification, which is based on ECDS, elliptic curve cryptography. In this case, what we will be using is a default crypto module that is running in the soft. We will be talking about as well third-party crypto such as KMS on AWS, and a way to hide the crypto complexities for the developers within the Kubernetes environment. So I will be, yes.
Sorry, before you go on, we're seeing your presenter side. We're not seeing the presentation, and there's some captions and things covering the content. I wonder if you could switch displays.
Can you see now?
This is the presenter mode that we're seeing.
Put it on
the presentation. If you put it in presentation mode, there's a choice to select whether you want to browse it. And that often is best. If you say I want to browse it in a window, then you can share the window.
I think the easy part is put it on a presentation mode, then shade, reshade.
Okay.
Yeah.
Yeah, this is the presenter side.
Okay, I've got two screens. I think one of my screen, perhaps Godfrey, can you take over?
If you go to presenter mode again, just do that now, and then you can switch screens.
Yes, thank you.
Okay, my screen, one of my screens is going on the other side.
See display settings? I believe under display settings, you can reverse the screens.
Okay, Godfrey, can you maybe take over the presentation mode, maybe?
If you stop.
Then I'll come back for the demo.
Okay, so if you stop on your side, then I'll be able to do that. Okay.
Okay, so if you can go to the next slide. So I'm using the YubiKey to basically interact with the FIDO system and also as an authenticator. I will be demonstrating in a minute. Can you show perhaps the next? So what we have is an application which is running as a relying party and a YubiKey that will be connecting to the machine. The relying party is running within Mojaloop, and we have a FIDO server that is talking to MongoDB, and then a CPM component that will be talking to a a default crypto component. And on the far end, we have AWS, the key management systems API that would be interfacing with on the long run. So can we go to the next, please? So the complexities that we are hiding basically is everything that is going on within the crypto environment. In this case, there's an API gateway. There's a serverless function that is running to basically orchestrates between the API gateway, Mojaloop, and the key management system and the key store that is provided by AWS as a third party. So I'm just going to run through a very simple demo. If I can take over.
Yeah, take it back.
Okay. Can you see my desk?
Yeah, you can see the logon page.
Okay, so basically what I'm going to do is I'm going to try and do the registration. Okay, so I'm just going to try and register. For some reason, my machine is a little bit slow. I'm going to put in my name, and I'm just going to put the username. At this stage, what is happening is I'm really using the low-level registration, which is the username and the password. So what will happen if I attempt to register? Okay, I've been trying to register before, so the system has detected that I am already in the system. So what I will do is I'll just try to log on as myself, do the login. So the system will basically ask me for to insert the UB key that I have in my hands. So I'm just going to put it in the machine. So now I'm elevating the level of security to basically enter the PIN that I would have created during the registration process. And if I say okay, the system and the authenticator itself will ask me to basically try and touch the UB key. And as a result, the login will happen. So I'm just going to try and register another user, perhaps. Maybe Godfrey. And see Godfrey here. And see if the system is going to detect. It's going to say, set up your security key in the local host as Godfrey. This request comes from Chrome. So I'm just going to say, okay. Okay, it's not a problem. And I'm going to put in the PIN. it will request me to touch the YubiKey, and I will log in. So what is happening at this stage is that the authenticator is creating, when we do the registration, a cryptographic elliptic curve public key and private key, and the private key stays within the YubiKey, and the public key basically is sent to the FIDO server to serve for further authentication should the user requires to return in the login. So that is in a nutshell
Thank you,
the
Amy.
simple demo that we've provided for this session.
Okay, thank you, Amy. Yeah, I think that was the last part of the presentation. So we'll just hand over back to the organizing team. If there's any questions or comment, we'll be available throughout the next 2 days.
Thank you all.